In this video, I'm going to cover Unit 3, Topic 3, solving a rational inequality. So, the first thing that you're going to do is I'm going to find a question that's actually an inequality. There we go. What you're going to notice is the question is going to say, express your answer in interval notation, along with this idea of there's going to be an inequality there. So please make sure, first of all, that you notice that. That's going to tell you this is an inequality. So you have to find the least common denominator. In order to do that, you're going to need to factor the denominators. So we factored this trinomial to get this. So our least common denominator, we have a factor of x minus 2. We have a factor of 1. Multiplying by 1 isn't going to change it. And then here we have this additional factor of x plus 7. X minus 2 we already have. So the least common denominator is going to be the product of those two factors. The denominator cannot equal 0, otherwise the function's undefined. So x cannot equal negative 7 or positive 2. So now we're just going to multiply by what's missing, or depending on what you learned in Algebra 2, you're going to multiply through by the least common denominator. So here, what's missing from this denominator is x plus 7. This denominator is missing both, and this denominator is missing nothing. So the x plus 3 times the x plus 7 just comes down. You'll notice the negative 1 here, and times this, and then the equals 10, because both denominators would simplify on the last one. Okay, you do some double distribution here using your square. You get this trinomial here. X plus 7 times x minus 2, we already know what that is. There's no point in doing the double distribution. It's going to be this trinomial here. Just keep that in parentheses, because in the next step, you're going to have to use the distributive property. That's what happens here. In this case, the squared term simplified to 0, and you're just left with the linear equation. You get x equals negative 5. So this is going to be incredibly important, because now what we need to do is we need to figure out the number line and what we can actually have as far as these values go. So we have less than or equal to. So in the calculator, what we're going to type in the calculator, we're going to do this x plus 3 divided by x minus 2. This is going to go into y1 minus 1 minus this 10 divided by x squared plus 5x minus 14. All that's going to go into y1 in the calculator. And technically, what else would be there is less than or equal to 0. We're not typing this part in the calculator, though. Okay, so just the part on the left here is going in the calculator. So all of this. Then we're going to look at the table. And on the table, we're going to look at numbers like less than negative 7. So say, oh, that's a line. That's not really helpful. Numbers less than negative 7, so like negative 8, negative 9. And we're looking at the y values to see, is this a positive or is it a negative? Anything below negative 7 is returning a negative, so that's why I put a negative here. Then we're going to look between negative 7 and negative 5. So in this case, negative 6 would be the only integer on there. That ended up returning a positive value. Between negative 5 and 2, looking at all those numbers, 0 is one of them. That returned a negative value. And then after 2, so every number after 2, you'll see on the table is going to return a positive value. Because it was less than or equal to, we are only interested in the negatives. So we're going to put this into interval notation, and you'll notice x cannot equal negative 7, so that's an open circle, and x cannot equal 2, open circle. Because this is less than or equal to, and x can equal negative 5, that's a closed circle. So we have this part of the number line that's being shaded and this part of the number line. So it's going to be from negative infinity to negative 7, open circle, so parenthesis in union with negative 5 to positive 2, a bracket at negative 5 because of the closed circle. And that's it, y'all. That's how you do a rational inequality.